guys, I'm back and I'm gonna try out experiment number 2. This one I've read ahead a little bit more so that I can hopefully reduce some of the pausing and reading during the actual recording. This one is all about kind of observing the properties related to shorting batteries and also to blowing fuses. And while these seem rudimentary to me, I still want to do them just because, that's my dog scratching. Ella, are you done? The whole world doesn't need to hear it. Okay, so anyways, we're going to go ahead and do the first part of this experiment, and that includes putting the battery, this is a good old-fashioned AA battery. I haven't tested the voltage on it or anything like that, but it's dated March 2017, brand new, so hopefully it's good. And we're just going to go ahead and put this guy in its holder. And there we go. And the first one of these is a little precarious. It is actually asking me to short the battery. So, just from personal experience, it's usually not a good idea, but I'm doing what they recommend and putting on a little bit of safety here. And the idea is we're going to use basic alligator clips and hold the ends of this together. And the book says if you wait about a minute, then the wires should be pretty hot. And if you were to wait another minute more, then the battery should start to feel hot and potentially a little too hot to the touch. So for the sake of performing the experiment, I will do what they said. In fact, I'm going to kind of, these are just little cork placemats, figure just in case anything were to go awry here, I want something to be kind of underneath this. So, before I touch these, get this guy ready. And we will put them together. So the wires are already starting to get a little warm. And the battery's actually starting to get a little warm too. And it's been a lot less than a minute so far. But yeah, it starts to generate more and more heat. Still just kind of warm. Wires are getting hotter, battery's getting hotter. So yeah, I would imagine over time this would probably be a very bad idea, especially with a stronger battery source. But yeah. So he's, I would say, temperature-wise, he's probably about, lukewarm. And I think that this was, done for probably closer to 1 minute rather than 2. I don't see the point in trying to melt down a battery on my tabletop here, but the point is definitely made. So I think the next step is to actually see. So this has, 1.5 volts of force behind, that push from the electrons. And right now, when you just connect, end to end, there's absolutely no resistance being offered up. So the electron flow is just able to, go unimpeded and basically discharge this battery as fast as it can. And that is what causes some of this. At least, in my current understanding, this is what causes all this heat buildup, both in the battery itself and the wires. So the goal behind using this fuse, and this is I believe it's don't think it's written on here, but I believe this one is a 3 amp fuse, as the experiment asks of us. And these kinds of fuses, let's see if I can make sure the camera can spot this guy. So these kinds of fuses are, they're very common in like automotive. So if you were to like look under your car fuse box, you'd probably spot like a big box of these. You know, they're all plugged in. So actually, I want to see if we can see to the inside of this fuse. Let's see here. So you see that there is the metal that is fully connected. Guess it's a little tough to see, but take my word on it. It's a brand new fuse. And we're going to go ahead and use that fuse and basically put that in the middle of this circuit. So one thing I'm not sure about is if we're going to be able to reuse this battery, because he might be kind of screwed up now that we shorted him out. So let me just see if the book had a recommendation on that. Yeah, they also recommended exactly what I figured. So put a fresh battery into the carrier, and I'll need to grab another alligator clip here. So give me just a sec. Zoom back out a little bit. Right. So let me grab a fresh battery here. Feel kind of bad about, you know, having potentially wasted the battery, but you know what? It's all in the name of science. So there's our fresh one. Yeah, even after all this time, he's still lukewarm, the battery. So there's definitely some damage, probably internal to this guy. So he will be disposed of later. Holder's even ever so slightly warm. So I'm gonna go ahead and put that in. And let me grab one more of these guys. Here we are. And this time we're going to set it up so that this fuse basically lives in between the circuit. And the idea is, since this guy does not provide really any resistance, he's just metal with a very thin piece of metal connecting these two posts. This essentially offers up no resistance, and so this flow will, in theory, provide more than 3 amps of current in a relatively quick amount of time, and this little wire will burst, disconnecting the circuit, essentially acting as a safety mechanism to prevent this battery and these wires from heating up. Now, of course, if the battery is not as you know, strong as it should be, then we may not blow the fuse. So I guess we will see. So I'm going to go ahead and take one lead and connect this guy to the first post. Let's see here. Maybe this is easier if I pair the wire up with one of the posts on the circuit, and then we can grab. It's kind of tricky to work with such small. Oh, I had it. One sec here. There we are. So we've got half of it there, and once we plug the other half in, we will pop the fuse, hopefully, if this goes as planned. So I'm going to go ahead now. Oh, and another thing to note is, because this is a more or less just a continuous path of metal. There's no, as far as I can see at least, there's no polarity requirements on this fuse or anything like that. So really it doesn't matter like if we were to put, you know, the positive lead on this side or on this side of the fuse. So bearing that in mind, the trick is going to be how quickly can I put this other post on so that I don't like get right in the middle of this action. So here's the idea. Let's see. Oh, I don't know if that was seen on camera, but that almost happened instantaneously. There was a very small spark the moment I touched, or the moment the alligator clips actually crimped down on the other post. So if I were to inspect this guy, that was a very small pop, ever so subtle. But yeah, looking very closely at it, the center of the fuse is actually darkened and disjointed now. Don't know if we'll be able to catch that. Let me try. We'll see if we can zoom in a little bit. Trying to see what's easiest for examining this little fuse. There we are. So the tip of that fuse is darkened, as you can kind of tell, and that is definitely blown. So I believe that is actually all that the book has for Experiment 2, but just to make sure, let me double check here. Yeah, the rest of this has to do with, you know, cleanup and recycling for the batteries, or the battery, and fuse. I don't believe there's any harm to throw away. I think that's pretty much safe to toss. So, yeah, alright, that's it. Hope you enjoyed Experiment 2. Again, it's pretty straightforward and simple right now, but it will definitely be ramping up. Stay tuned.